Hello, welcome students in this session for rational numbers. This is the third part of the chapter that we are doing actually. The chapter is rational numbers, which you have studied already in class 7, that was introduced in class 7 rather. We have discussed something about this in our previous two sessions, and I want to carry it further, because after the introduction of rational numbers, we need also to see what is the behavior of these rational numbers, in the sense which is the largest one, which is the smallest one, and what is the relation with the integers, natural numbers, and so on. So, generation of numbers is not just sufficient, but its relation with other concepts and its application as well to the other concepts is also important. And so, we carry forward our discussion about rational numbers. I discussed some of the questions rather, and one of them was what should be added to -1/2 to get a natural number, nearest natural number to -1/2. I continue this and I ask you, what should be subtracted from -2/3? What should be subtracted now from which number? Subtracted from -2/3 to obtain the nearest integer. So, we were trying to locate the integer that is nearest to -2/3. Number line is the most powerful tool that helps us to simplify the problems, the thinking process. So, I am visually, because it is a visual thing that I am able to see here. So, let us draw number line here, and on this number line I am trying to see what is the nearest integer to -2/3. This is -1, this is -2, of course, this is 1 and 2, and it proceeds on both sides infinitely. Now, in order to see what is -2/3, I will divide this into 3 equal parts on the negative side, that is between 0 and -1. So, these are the 3 parts here, and now the first part becomes -1/3, the second part becomes -2/3. This is -1/3, this is -2/3. You know how to locate fractions on the number line. The only thing here is you have to do it on the negative side, that is to the left of 0. So, this is -1/3, this is -2/3. Now, you can see which are the two integers here. It cannot be definitely nearer to -2 or -3. It has to be either nearer to -1 or 0. And see, from these sections that you see here, how many sections are there here? 1 and 2 section before you reach 0. 0 is one of the integers, but you have to jump just once here. You have to jump just once, whereas to reach 0 you have to jump twice. So, which will be the nearest one? -1 will be the nearest integer to -2/3. So, in this way, first of all, let us try to find what exactly we want to do, what exactly we want to find, and then we can convert this into the mathematical language, into equations or whatever it is, and then we can see what can be the answer. Now, what can be the obvious answer here? What should be added to -1/3? Look, from -2/3 I am proceeding towards -1, one jump of 1/3 I am taking here, and to which side I am going? I am going towards the left. According to the conventions of number line, I will say that I have added -1/3, or I have made one jump of -1/3, that is from -2/3. If I go to -1, it means I have added -1/3 here. Other way of doing this is -2/3 plus x is equal to -1. Shifting this, you know how to do this now, add 2/3 to both the sides. So, shifting this, I will say x is equal to -1 plus 2/3, and if you simplify this using LCM, you will find that this is nothing but -1/3. So, visually I tried to show, and you try to see how the number line can be used to get this particular solution. That is, one jump of 1/3 to the left took me to -1, and here in an equation form, if I add x, if I say that the particular number is x, then I solve the equation, I get the value as -1/3. Now, continuing this, I will say what should be multiplied. We are taking all the 4 operations, addition, subtraction, multiplication and division, and look at the numbers that I am using here. Nearest natural number 2 minus 1 by 2, nearest integer 2 minus 2 by 3, I wanted to obtain this by subtracting some number from minus 2 by 3. Now I want to multiply minus 5 by 8, now I want to multiply minus 5 by 8 with some number so that I get the nearest integer. So first of all my job would be to locate the nearest integer on the number line and see which is the number here. Let us try to see this now. I am trying to locate this minus 5 by 8 first of all on the number line. Now this is minus 1, I am taking slightly larger integer here number. This distance I am taking, magnifying this particular distance so that we get a better idea of this. I want to mark minus 5 by 8 on this number line. So I divide this into 8 sections 1, 2, 3, 4, 5, 6, 7. There are 8 sections, you can see 1, 2, 3, 4, 5, 6, 7, 8, and out of these 8 sections I want the 5th one that will give me minus 5 by 8. So this is 1, this is minus 1 by 8, this will be minus 2 by 8, this will be minus 3 by 8, minus 4 by 8, and this will be minus 5 by 8. I have located minus 5 by 8 on the number line, and the question is which is the nearest integer now? Out of this minus 1 and 0, which integer do you think will be the nearest one? How will you see that? Will you try to measure it? You can do that also, but try to think of a process of doing that. Try to see how many jumps you have to take to reach 0. You have to take 1, 2, 3, 4, 5 jumps or 6 jumps here from this to this, this to this, this to this, this to this, this. How many jumps to reach minus 1? You need 1, 2 and 3 jumps to reach minus 1. So 5 jumps to reach 0 and 3 jumps to reach minus 1, which is the shortest one. You will find that reaching minus 1 will be shortest, means minus 1 is the nearest integer to minus 5 by 8. So this is what we have decided now. So you plotted a number line, you represented minus 5 by 8 on the number line, divided this into equal parts and saw which particular number is nearest to, which particular integer is nearest to minus 5 by 8, and then you can see how many jumps are there. There are 3 jumps, 1, 2 and 3. 3 jumps of how much distance in each jump, how many steps in each jump? There are 1 by 8, 1 by 8. One jump will cover a distance of 1 by 8. 3 jumps will cover a distance of how much? 3 by 8. And this particular transition is from in which direction? It is towards the left. So I will say that it is minus 3 by 8, means it means that if you add minus 3 by 8 to minus 5 by 8, you are going to get minus 1. So try to visualize the thing, try to find out your own ways of calculating it, not just the conventional ways, and you can do it using an equation as well that you are now well aware of. So that was about the addition or multiplying a number. For of course, when I was talking about multiplying a number, minus 5 by 8 multiplied by x is equal to minus 1. We have come to our conclusion that minus 1 is the nearest integer to minus 5 by 8. So I want to find a number which I call say x, which when multiplied to minus 5 by 8 will give me minus 1. And so we use the process of solving an equation. Here it is minus 5 by 8 multiplied by x. So what I do is I divide both sides by minus 5 by 8, so that here I get 1 and there I get the desired number. So x is equal to minus 1 upon minus 5 by 8, and that is nothing but 8 by 5. So the value of x is 8 by 5. I should multiply this minus 5 by 8, I should multiply this minus 5 by 8 by 5, and you can find that this is nothing but minus 1. So multiplication of this number by 8 by 5, but in order to do that you have to look at the two words, the two things that are important here. One is nearest integer that can be found by using the number line, and the other thing is which particular number should we take. So we solve the equation. So we suppose a number to be x, solve that particular equation, but while solving the equation now, since multiplication is operation is there in between the two, you have to take appropriate care of dividing both sides by minus 5 by 8. And then of course, after establishing this, try to check whether your answer is correct or not. So, I have checked it, I have multiplied minus 5 by 8 to 8 by 5, and you know the multiplication process, you get minus 1 here. The next one in this series is what should be divided by 1 by 2 to obtain the greatest negative integer. The term here, look at the term here, greatest negative integer. So, can you say that there is any least negative integer? Think about it. Can you say that there is any greatest positive integer? Think about it. Let me plot it on the number line first to see which is the greatest negative integer. This is 0, this is 1 and so on, this is minus 1, minus 2 and so on. This particular series of numbers you can see, suppose I start with minus 10, it is minus 10, minus 9, minus 8, minus 7, minus 6, minus 4, minus 3, minus 2, minus 1 and then 0. But the sequence of the negative integers stops at this. The sequence of negative integers stops at this. This is neither negative nor positive, and then the positive integers start. So, which one do you think is the largest negative integer? Can you say minus 2 is the largest? But minus 1 is greater than minus 2, minus 2 is greater than minus 3, minus 3 is greater than minus 4. So, as you proceed to the left, you will find that the value of the integers, they are decreasing. So, we can say that minus 1, which is nearest to 0, will become the greatest negative integer. So, you have to use your previous knowledge about integers to establish first of all which is the greatest negative integer. And now again you can follow the same process here. If I suppose the number to be x, mind the words here, what should be divided by 1 by 2? I say that suppose x is divided by 1 by 2, x divided by 1 by 2 gives me minus 1. When I simplify this now, what I find here is I have divided some number here and I do not want this number here. So, what I do is I multiply both sides by 1 by 2 so that I get 1 here. So, I can say 1 by 2 multiplied by x upon 1 by 2 is equal to minus 1 multiplied by 1 by 2, transposing the number to other side. It depends on the operation which is there. Here the operation is multiplication. So, in order that I remove this here, I multiplied it by 1 by 2, these two numbers will get cancelled here and finally, I get x is equal to minus 1 by 2. It means that I should divide minus 1 by 2 by 1 by 2 to get the largest negative integer, that is nothing but minus 1. Let me check it once. So, I can say that minus 1 by 2 divided by 1 by 2, that is nothing but minus 1 by 2 into 2 by 1 and I get minus 1 ultimately. So, in this way I have been first able to locate which is the greatest negative integer and then I formulated it in the form of an equation and then I solved the equation to get the required number. So, these are the stages that are important in while thinking about the problem. Try to see what the words say, and that is why whenever you try to discuss some concept, whenever you try to understand some concept, the best way is to discuss with your teachers, to discuss with your peers, to discuss with your friends. The words are important and they convey some meaning there, and these meanings have to be understood, and that will help you in understanding the concepts of mathematics. So, in order to further look at these particular concepts, let us see now one more question which says that a and b are two different numbers. Mind the words here, a and b are two different numbers taken from numbers 1 to 50. You have got a pool of numbers here 1 to 50, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 up to 49, 50. These are the numbers given to you, and from these numbers you are taking two numbers a and b, and these two numbers are different from each other. The question is, what is the largest value of a minus b upon a plus b? Let us think for a moment what can be the largest value here under the given situation. If I take suppose a is equal to 20 and b is equal to 2, I will get here 18 upon 22. If I take a is equal to say 21, b is equal to 19. Try these different combinations here, and then finally you can settle down to the idea, what if I take a as 50 and b as 1? If I take a as 50 and b as 1, the numerator I get here is 50 minus 1 upon 50 plus 1. The final value of a minus b upon a plus b that I get is a minus b upon a plus b is 50 minus 1 upon 50 plus 1. After trying some combinations, you can arrive at this. You know how to compare rational numbers, you know how to compare fractions. Try to see about their denominators, try to make them equivalent fractions, you will get the difference and see what pattern it follows. Now, here I find that this particular thing is nothing but 49 upon 51. Now, it cannot exceed 50, because one of the numbers has to be from 1 to 50, the other one also has to be from 1 to 50. I cannot take 51 and 1, because it would have given me 50 otherwise, but I cannot do that. So, I have to take here 50 and 1, that is 50 minus 1 upon 50 plus 1, and this is the largest value I am getting here. So, my request would be, at your end you try to take different combinations of a and b and try to see whether this particular fraction or rational number that you are getting is the largest one or not. The other question that is there is, what is the largest value of a plus b upon a minus b? If I want the largest value, now here a little thinking will help you. If I want the largest value of the fractional form of a number in the fractional form, it is important that numerator should be maximum, denominator should be minimum. So, when I say here, if I take here a is equal to say 49 and b is equal to 1, I will get here 50 upon 48. If I take a is equal to 50, I cannot take b as 50 again, so I take b is equal to 49. Look at this combination, this was 49 plus 1 upon 49 minus 1, which means 50 upon 48, but here what you get, 50 plus 49 divided by 50 minus 49, and so you get the combination as 99 upon 1 or simply 99. The numerator has to be maximum, denominator has to be minimum, and that is what we have done in both the cases. The general principle that goes behind it, you will automatically understand this particular principle, and I expect that you try to formulate it, try to generalize it. When can this happen? And that is going to help you in understanding the other concepts of mathematics as well. So, friends, till now we have discussed about the different numbers, the different concepts about rational numbers, but in the earlier classes you have already studied about natural numbers. You have already studied about natural numbers, the numbers of the form 1, 2, 3, 4 and so on. We found that this natural number, this particular thing is contained in the box of whole numbers. This is contained in the box of whole numbers. You put in 0 and you get a different collection of numbers named differently, which we call as whole numbers, and again these whole numbers we put in some more numbers that we call negative numbers and form another collection of numbers that we call integers, So, you have minus 3, minus 2, minus 1, 0, 1, 2, 3 and so on. It will contain whole numbers, it will contain natural numbers also, and now at the end we have come to these numbers that we call as rational numbers. So, all these numbers, all these collections of numbers, they are contained in the collection of rational numbers. And here at the moment, because in higher classes some more number systems could be added, and there you will be required to prove something, to disprove something based on logical conclusions. So, that is why it is pertinent to note that you try to follow this particular sequence of numbers that you have studied and see what are the interrelations between them. and this is going to help you to understand the concept of rational numbers and other number systems. We have discussed something about rational numbers, and at every step what I was doing is I was comparing these rational numbers with the already studied numbers, and in this particular comparison I was trying to see what are the interrelations between these collections of numbers. Now let us see how these rational numbers behave under the different operations of addition, subtraction, multiplication and division, and how the other numbers that you have studied till now were behaving under the same operations. Let us take the first one. Before naming that particular property or that particular behavior, I would like to give you an example. Suppose I take two numbers 2 by 3 and add them under the operation of, say, addition. I have taken two rational numbers 2 by 3 and minus 1 by 3. I am adding these two rational numbers now. What do you get here? I get here 2 minus 1 divided by 3. I have taken the simplest of all rational numbers that will help me in calculating them, and so I find that this is 1 by 3. You take several such pairs of numbers, try to add all these numbers and see what kind of number you are getting here. Is it strictly an integer? Is it strictly a natural number, or is it strictly a rational number? So, every time I find that if I add two rational numbers, even if I add these two numbers 2 and minus 7, suppose, even if I add these two numbers, aren't they rational numbers? They are also rational numbers. So, when I add them, what kind of number do I get? I again get a rational number. Here also I am getting a rational number. If I add a number like this, 1 plus minus 2 by 3, what kind of number will I get here? I will get here again a rational number. I will get again here a rational number. Which two numbers are being, which two types of numbers are being operated? 2 by 3 minus 1 by 3, rational numbers. 1 and minus 2 by 3, rational numbers. 2 and minus 7, rational numbers. What is the operation between them? Addition is the operation between them, and every time after operating in this, you are again getting a number which is not going out of that box. The box that I have shown you here, it is not going out of that box, and so we can say that they are closed under this particular operation. The word closed is used in this sense that whatever two numbers you are getting from that box of rational number, they are not going out of it, they are remaining in that box only, means it is closed box, there is no space for that if the two numbers are rational numbers. We say that this is the closure property for rational numbers. So, what does it say? That if you add any two rational numbers, closure property for addition of rational numbers will say, if you add any two rational numbers, you are going to get again a rational number. Will it hold for integers also? Will it hold for whole numbers also? That you can check for yourself. Take two whole numbers, try to add it. Do not take one whole number and one integer. Whatever numbers you are taking, they should be from the same collection of numbers. Either both of them should be whole numbers, or both of them should be integers, and so on and so forth. What will happen if I talk about subtraction of numbers? When I say 2 by 3 minus of 1 by 3, 2 by 3 minus 1 by 3, what do you get here? I get 1 by 3 again. Try out different rational numbers, negative rational numbers, positive rational numbers, and take lots of pairs and try to subtract them. You will always find that you are getting a rational number there. So, we say that the rational numbers are closed, rational numbers are closed under the operation of subtraction. Will it hold for natural numbers? For addition, it is okay. You can say that 2 plus 3 is equal to 5. As far as addition is concerned, and when I am talking about the collection of natural numbers, you will find that it is closed under the operation of addition. But will it be closed under the operation of subtraction? Take the same thing here, 2 minus 3. 2 minus 3, do you think will be a natural number? It will not be a natural number. You are going to get here minus 1, which is not a natural number. Not a natural number. It means that under this particular operation of subtraction, two natural numbers when they are operated, every time you may not get a natural number. That is more important to speak in this way. You may not get, and when you say you may not get, means it is not closed. In mathematics, we are using words in that precision. it have got some meaning here, and it is important that you understand the meaning of those words. So, it is not closed when I say I have got one example with me to say that there is at least one pair of natural numbers whose subtraction is not going to give me a natural number. My conclusion is natural numbers will not be closed under the operation of subtraction. So, we are going to study some more properties and the behavior of rational numbers in comparison to the numbers that you have studied till now, and we will see how, as the number system progresses, some of the properties they hold and some of the properties in the earlier number systems that they do not hold. So, which are these properties? It will be interesting to see. You can make a chart of this and find for yourself also to see which are the properties that are not held. For example, here it is not closed, natural numbers is not closed under subtraction, but integers and rational numbers, they will be closed under subtraction. So, these things are interesting to be seen, and I advise you that you should try to see as many pairs as possible, share it with your friends, with your teachers, and do not just calculate and do it. Try to give your observations and comments on that. What do you think about that particular property, or whether it holds or it does not hold, why it holds, why it does not hold. These are the things of discussion that will deepen your understanding of mathematics. So, friends, we started our discussion with some of the problems that were based on rational numbers, and we discussed these problems in relation to whatever concepts you have studied about the numbers and the concepts related to these numbers in the earlier classes, the natural numbers, whole numbers, etc., and how they hold, or whether they hold in the case of rational numbers or not, why they do not hold in the other number system, so on and so forth. So, in this particular session, it's all over now. I would like to take your leave. Thank you so much. In other sessions, we will further continue with the concept of rational numbers. Thank you so much.